Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at feeder sizes and feeder IDs in ElectroBIM. If you're attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can contact our support team using options on our website. So what I want to talk about today are feeder IDs, and specifically the fact that ElectroBIM handles feeder IDs a little bit differently from how you were using them previously. So feeder IDs are these IDs, these labels here that show up on the single line diagram that have some sort of marker indicating the size of that wire. They point over to a feeder schedule that you have on your single line diagram. So you have the feeder ID shown here, and then you have the corresponding wire size. And there's various ways you can do that. Out of the box, our software, we're displaying the whole wire callout. Some people like to separate that with columns for each wire size. But the idea is that the feeder IDs that go on the single line diagram are a shortened version of that wire size. And then the full wire callout with the conduit size and the ground size and everything else, you look up on the feeder schedule. The reason that ElectroBIM is different is that previously, before you're using our software, people tend to think in terms of feeder IDs. So they think, I want a 100 feeder size for this feeder. So they're thinking, I want to put a 100. And if they want to change that, they're thinking, okay, I want that feeder ID to be 125. And so they're thinking in terms of the feeder IDs, whereas ElectroBIM is thinking in terms of the actual sizes of the wires. It's thinking, I want a number 1 or I want a 1/0. And then it's generating that feeder ID from it. So just as an example of how this works when you're doing this by hand, I have a couple feeder schedules that I've collected over the years. These were sent to me by customers. So you can see that this one here, you've got your feeders, it's F1 through FA26, and they correspond to a wire configuration. Got another one here, you've got copper aluminum with different symbology. You've got the different sizes. The aluminums have some X's up here. Another one, this looks like it's all copper, but again, different feeder sizes. This is a shorter one with just a couple different feeder sizes on it. This one was really long. I had to kind of crop it out because it was too tall for my screen. But this has different feeder sizes again, and then those different, they call them tags. We call them IDs. The wire size and the conduit are separate columns. If you ever wonder why we have so many options for feeder IDs, this is the reason. Because we need to accommodate feeder schedules of this variety. I've got 5 different schedules. Every single one of these is very, very different. You can actually do all of these with our software. So we have all of the customization built into the feeder IDs so that we can handle things like that. So if you ever wonder why do they have all of these options, this is why. But when you're using these, the way it works is you plop this on your single line diagram, and then you just start labeling your feeders using the IDs. So you do an F1 for a number 12 wire. If you have a 1/0 wire, you would do an F8. If it's a number 1 aluminum, you're going to do an FA7. Actually, no, this is a 3 and a 4 wire. So anyway, you got to make sure you're using them right. So for a 4 wire, you would do an FA7. And then if you wanted to change that wire size, you would just put in a new feeder ID. So if you want to upsize that number 1 to a 1/0, you change it from an F7 to an F8. And that's what you would do. You would go on your single line diagram and you physically change that ID. ElectroBIM works a little bit different from that. And so I just wanted to highlight how we are different. So you don't, if you want to change a wire size, you don't come in here and say, okay, I'm going to change this 250 to a 300. This is actually a good example. We've got a system. We've got voltage drop here. We're over 3%. We really actually need to change this feeder size. Previously, what you would do is you just come in here, you'd cross out that 250 or you would erase it in CAD and you'd write in a 300. And that's how you get that new wire size. Of course, then you have to go put that new wire size everywhere else. Our software obviously helps with that as well. But you're just changing some text on here. And then that 300 is going to point to a new wire size on the feeder schedule. If you're using this feeder schedule, you'd be going from this F12 up to an F13. Now, a quick quiz for you here. If you made that change, why is it not actually going to work if you just change it from an F12 to an F13? What gets missed if you just change it based upon this feeder size? You're going to test your engineering knowledge. Who knows off the top of their head what else you need to adjust when you're adjusting a conductor size for voltage drop?
Ground size.
Ground size. Thank you for whoever said that. You can't just upsize the conductor size. You also have to upsize the ground. So you actually can't cross it out the F12 and just type in F13 because this ground size is the same. You actually need a new ground size in there. So that's why Design Master is thinking not in terms of IDs, but in configurations of wires and conduits, and then the ID flows from that. So to change this, we don't come in here and change. You don't want to change this ID. You actually want to come to this panel and you want to change this wire size. So we run our edit command. We select PP2B, and it has this call out. It has this wire size, which has a corresponding ID, but you're not changing the ID. You're changing the conductor for voltage drop. So you tell our software, I want to change the conductor. It doesn't know it's for voltage drop, but you just say, I'm going to change this conductor. So I'm going from the 250 amp to a 300 amp wire. So from 250 kc mil to 350 kc mil. Currently, it's a number 4 ground. You make that change, and it's going to upsize those conduits. It also upsizes the ground. So now it's labeling it with that number 2 ground. Okay, so that's good. That's why you're using our software. That's the benefit that you get. What that means is that feeder ID is not a 300. It actually needs to be something different. In this case, it's a 300A. Our schedule doesn't update automatically. I'm going to insert the schedule. So now we have a 300 and a 300A. So this 300 corresponds to this panel. It's a 300 amp panel, standard 300 amp feeder with a number 4 ground. We upsized this one to be the same size conductors, but since we are upsizing for voltage drop, we also have to upsize that ground. So the software recognizes that this is actually a different configuration and gives you that different feeder ID. So ElectroBIM is thinking in terms of configurations of wires, and then the feeder ID is a result of that. You're not thinking in terms of feeder IDs that drive your wire sizes. It's wire sizes that drive your feeder IDs. So it's an inversion of how you were doing it previously. If you're just slapping a feeder schedule on your sheet and then pulling labels off of this to size your wires. That's not how we're doing it in ElectroBIM. We're sizing the wire and then generating that schedule based upon the wire sizes that you are using in the project. It also means that your feeder schedule is going to be smaller using our software. If you want to, you can get these matched up to our software and you can put the whole feeder schedule, but this has all the wire sizes you might ever possibly want to use. Actually, not even all of them. It has a set of them, but a large set. We instead show you the feeder IDs that are being used on this single line. So every one of these is in active use on this single line diagram. So it's a smaller set of IDs. It's not necessarily better or worse. It does make for a slightly smaller, more compact feeder schedule. And since we're generating it, there's no loss of information to not have those other feeder sizes in there. If you're doing it by hand, it's handy to just have all of the feeder sizes available so you can just use the ones that you need and not having to remember to go back and update that schedule. All of these feeder IDs are in our customization. We have the project feeder ID schedule. We have the master feeder ID schedule. So this is all the lists of the feeder IDs. And part of the reason you don't really actually want to list them all is that it actually gets to be a really big list. So like just this 20 amp, we've got 4 different options for 20 amp wires based upon whether it's a 3-pole, it's got 3 wires, if it's got just a single wire, whether or not there's a neutral based upon different ground sizes. So the feeder schedule, if you include every possible configuration, very quickly blows up. So we don't try and show them all. We show just the ones that you're using. But these are the ones it's going to pull from. If it needs that feeder ID, it's going to use these ones that have already been created. We have another training. If you're watching the recording, we'll link that up in the show notes, showing you how to do all the configuration and customization of these feeder IDs. There's a lot to it. Again, because we can support any one of these schedules. So we've got a lot of different options in our software to support all of these. Thank you for watching today's ElectroBIM training. Contact us with questions or comments by emailing support@designmaster.biz.